Imagine a time machine, not of metal, but of the mind, taking us 2 billion years into Earth's past. We arrive on a planet both familiar and alien, Earth in its adolescence, raw and untamed. The air is thin, sharp and metallic, the sky a hazy orange, the sun dimmer through a strange veil. This is the Proterozoic Eon, a chapter written not in fossils, but in the chemistry of ancient rocks. There are no forests, no grass, only stark rock and dust shaped by wind and water. Silence dominates, broken by wind, waves or distant volcanoes. The world waits, for oxygen, for life's next leap. We stand on a primeval shore, witnessing monumental changes happening invisibly in ocean and air. Every grain of sand, every ripple, every bubble of gas, is part of a story of transformation. The stage is being set for the grand drama of life. This is a privileged glimpse into the scale of geological time. The changes here are slow, deliberate brushstrokes painting the masterpiece of our world. Let's explore this lost world, uncovering secrets of our planet's deep past. Marvel at the resilience and enduring power of life itself. Our journey begins at the dawn of everything we know. Look up. The sky is a pale orange, tinged with pink, filtered through methane haze. Earth's air is almost devoid of oxygen, thick with nitrogen, carbon dioxide, and methane. This greenhouse mix traps heat from a fainter sun, keeping the planet from freezing. Without oxygen, there's no ozone layer. Ultraviolet radiation pours down. The thin air, perhaps half today's pressure, makes the world quieter, more subdued. Water boils at lower temperatures, winds carry less force, and sound barely travels. Only microbes thrive here, breathing gases poisonous to us. But change is brewing. Deep in the oceans, tiny organisms are harnessing sunlight. Through photosynthesis, they release a waste gas, oxygen. At first, this oxygen is absorbed by iron in the oceans. Soon, the world will be transformed as oxygen begins to escape into the air. The stage is set for a revolution that will forever alter the sky and the destiny of life. The countdown to the Great Oxidation event has begun. The air, the sky, and life itself are on the brink of transformation. Gaze at the surface. Earth is a world of water, its oceans vast and murky, colored by dissolved iron. Oxygen produced by early life reacts with this iron, forming banded iron formations, ancient fingerprints we mine today. The continents are barren, eroded by relentless wind and rain, painted in reds, browns, and grays. No green softens the landscape, it's a raw geological sculpture. Volcanic activity is rampant, with shield volcanoes pouring lava and hydrothermal vents spewing minerals into the sea. These vents are oases for early life, providing chemical energy in the dark depths. The land and sea are in constant flux. Continents drift, mountains rise and erode, rift valleys tear the land apart. The planet is geologically hyperactive, restless, and dynamic. This turmoil drives evolution, shaping the world's future. The ground beneath our feet is alive with energy from Earth's core. Rivers run thick with sediment, carving the land and feeding the oceans. The landscape is ever-changing, a testament to the planet's youth. Life clings to the margins, adapting to extremes. The world is in the process of making itself. Every feature is a clue to the story of Earth's transformation. Life exists here, but it's small. Microbes, single-celled pioneers, rule the planet. Bacteria and archaea thrive in the vast, shallow oceans, resilient to low oxygen and high radiation. Among them, cyanobacteria master photosynthesis, releasing oxygen as a byproduct. For millions of years, this oxygen is absorbed locally, but the cyanobacteria persist. They form slimy mats in coastal waters, leaving behind fossilized stromatolites. Layered mounds, ancient evidence of life. Stromatolites are microbial cities, complex ecosystems built layer by layer. Cyanobacteria capture sunlight. Other microbes feed on their waste or dead cells below. These communities create structure and order, trapping sediment and building coastlines. They are the first reef builders, long before corals. In the deep sea, life relies on chemosynthesis, drawing energy from minerals at hydrothermal vents. Extremophiles thrive in darkness, heat, and toxicity, independent of sunlight. This hidden biosphere is a separate kingdom, only now being understood. Microbes are the architects, quietly transforming the planet. Their persistence sets the stage for all future life. The world above and below the waves is shaped by their invisible work. Life's first great experiment is underway. Cyanobacteria's relentless photosynthesis triggers the Great Oxidation event. For eons, oxygen is soaked up by iron and minerals, but eventually, the sponge is full. Free oxygen begins to accumulate in the atmosphere, a catastrophe for anaerobic life. Oxygen, a deadly poison to most microbes, causes a mass extinction. Survivors retreat to oxygen-free refuges, while the world is terraformed by its own inhabitants. The new oxygen-rich air allows an ozone layer to form, shielding the surface from ultraviolet radiation. For the first time, land becomes a safer place for life. Oxygen reacts with methane, removing this greenhouse gas and plunging Earth into global ice ages, the Huronian glaciation. The planet may freeze over entirely, reflecting sunlight and locking in a planetary winter. Life clings on beneath the ice, waiting for the thaw. The rise of oxygen nearly extinguishes life, but resilience prevails. This event paves the way for future complexity. The world is forever changed by the innovation of photosynthesis. The continents are united as Columbia, a vast supercontinent surrounded by a global ocean. Its assembly is slow and powerful. Ancient landmasses collide, raising immense mountain ranges. Without plants, these mountains erode quickly, their sediments washing into the sea. The interior of Columbia is a harsh desert, far from ocean moisture, with extreme temperatures. Most life clings to coastlines and shallow seas. The supercontinent's size shapes ocean currents and weather, creating a unique climate. Geologists piece together Columbia's existence from ancient rocks scattered across today's continents. These rocks are puzzle pieces, revealing a dynamic, ever-changing planet. The story of Columbia reminds us that Earth's surface is never fixed. Plate tectonics continues to reshape our world. The legacy of supercontinents is written in the land beneath our feet. Earth's climate is wildly unstable. Our sun is fainter, yet greenhouse gases keep the planet warm. High methane and carbon dioxide trap heat, but the rise of oxygen destroys methane, triggering a deep freeze. The Huronian glaciation may cover the planet in ice for millions of years. Oceans are sealed under thick ice. Life survives in isolated pockets. Even outside ice ages, the lack of vegetation means land heats and cools rapidly, driving violent storms and flash floods. Weather is raw and untamed, with extremes of temperature and precipitation. Volcanoes erupt beneath the ice, slowly releasing carbon dioxide. Eventually, greenhouse gases build up, melting the ice in a dramatic swing to hothouse conditions. The planet cycles between deep freeze and intense heat. These extremes define the era, shaping evolution and the environment. Life endures, adapting to every swing. The climate's volatility is a powerful force in Earth's story. The world is forged in fire and ice. Compare ancient Earth to today, a blueprint versus a finished cathedral. Our sky is blue, rich in oxygen. Theirs was orange, filtered through methane. Today's continents are green and alive. Then, they were barren rock and dust. Modern oceans teem with life. Ancient seas were murky, iron-rich, and home only to microbes. Evolution now moves quickly. Back then, change was glacially slow. The rise of oxygen took millions of years, setting the stage for future complexity. Yet, the connection is clear. The oxygen we breathe, the iron we use, the continents we inhabit, all trace back to this ancient world. Our genetic code descends from those first microbes. We are the legacy of that alien planet. The transformation from simplicity to complexity began here. The echoes of that world shape our own. The past is alive within us. We are the children of Earth's distant dawn. Why care about this distant world? Because it's our origin story. Understanding ancient Earth reveals the conditions that make a planet habitable. As we search for life elsewhere, these early worlds are our template. The Great Oxidation event shows life as a powerful geological force, reshaping atmosphere and climate. Our own impact on the planet is now millions of times faster. The past offers cautionary tales and perspective on our present. Exploring this lost world inspires wonder and curiosity. Holding a piece of ancient rock connects us to a time before dinosaurs. This was the beginning of breathable air, stable climate, and the pathways to complex life. By looking back, we appreciate the vibrant world we now call home. The echoes of that lost world are all around us, and within us.